All right, so let's start by going over the checkpoint from yesterday, and what do y'all think was the most missed question in this entire thing? So, okay. Number 4, actually, which kind of sort of blows my mind because number 4, I had 8 people out of 10 miss this. Okay. I was asking how are frequency and period related in simple harmonic motion. I have written up on the wall here, what does that mean? What is F? What is T? You don't say time. Period. How are they related? Inversely. They're inversely proportional. So if you've got a wave, right, passing a certain point, let's say it's passing this point right here, traveling this way, okay? If it passes this way once every 10 seconds, okay, then is that period or frequency? That is period, okay? So if it passes once every 10 seconds, then what would the frequency be? Okay? The frequency would be, wait a minute. Hold on. Okay. That example. How am I not wording that right? Why does that not make sense? Because I was about to say then frequency would be, okay, yeah, no, frequency works. Frequency would be 1/10 of a hertz, right? Okay? Or 1/10 of a cycle every second if it takes 10 seconds for one whole cycle. That doesn't make sense. Okay, so number 4 is just trivial. I do want to remind everybody that I'm recycling questions on the semester test. I'll tell you more about the semester test that I've got worked up so far. There might be some minor changes between now and tomorrow, but I'm thinking I really like how things turned out. Next most missed question was number 7. So let's take a look at that. String vibrates with a standing wave that has a wavelength of 1.2 meters. The standing wave has the pattern shown above. So we're looking at this pattern up here. It wants to know what's the length of the string. So if a lot of people tried to make this a math problem, and it's really kind of not, right? Looking at this up here, I have one complete wave here. So that right there is one wavelength. Okay? How much of a wavelength is this? Okay? This is 0.5 wavelengths. So I have 1.5 wavelengths here. So if the wavelength is 1.2, and this is 1.2, this would be 0.6. What's the length of my string? 1.8. Make sense? That was tricky. And I knew it was tricky because it tricked everybody last year too. Okay? Don't be afraid to remember that it's not just all about mashing numbers and formulas. It's about taking a mental step back and seeing what it's actually done, and seeing what, if anything, actually makes sense. Folks did really great on 8 and 9. I did have, well, let's go back to number 1 real quick. Because I had 6 people miss number 1. Which of the following types of interference will occur when the pulse is in the figure above me? We did the thing out in the hall with the shaky on the snaky or whatever. And what happens is that when this wave and this wave come together, at some point, probably around right here, they are going to sort of move through each other, but as they move through each other, they are going to kind of combine their heights, and so you're going to end up with a wave that's like, at just a moment right there, they're going to build on each other and then continue on with tall boy right here, continuing to go that way, short boy right here, continuing to go that way. Okay? But at that moment where they come together, they build on each other. Keyword build. What kind of interference is that? Constructive. Now what happens if you've got, say, a wave pulse like this, and a wave pulse like this, and this one's going this way, and this one's going this way? When they meet, what's going to happen? They're going to kind of cancel each other out for just a minute as they pass by. Okay? And that would be constructive. Tear each other down. All right, 5 people apiece miss number 6 and number 10. We're back with this guy again. And this just has more to do with terminology than anything else. It wants to know how many nodes and antinodes. So a node is a place where there is no movement from an outside observer. So that's a node, right? That's a node. Do I have any others? Right here and right here. So I have a total of 4 nodes. And that's the only one that gives me 4 nodes. An antinode would be the place where it's at its most extreme movement. I just remembered I've got this really cool wave flow that I need to get out and answer those over that you can make standing waves in real time. I'll get that out and show you this week. But that's our answer right there. Node includes the 2 ends right there. And then number 10. Number 10, I think for some people, it was probably just a calculator issue. Okay, because it was giving you stuff in scientific notation. Radio waves have a frequency of 95.9 megahertz if the waves travel at the speed of 3 times 10 to the 8th. What's interesting about 3 times 10 to the 8th? What speed is that? You've heard that before. It's the speed of light. Speed of light and light. Okay, because radio waves and light are the same thing. They have the same speed. So it wants to know what the wavelength is. So if we start from velocity equals frequency times wavelength, we're trying to find wavelength, so we divide both sides by frequency. So velocity over frequency equals wavelength. Okay. So now the way that I put this in my calculator is I would put 3 times 10 to the 8th divided by, now since 1 megahertz is 1 times 10 to the 6th hertz, I'd go 95.9 times 10 to the 6th. And then it should give you your answer, which was about 3.13 meters. Okay. All the other questions on here, we had less than 5 people missing. I had 4 people miss number 2, 4 people miss number 5, and then 1 person apiece on 3, 8, and 9. So I'm going to give you a moment or two to confer with people sitting nearby and get the answers for any questions you might have missed. And if you're not sure why you missed them and nobody around can tell you, let me know and we'll take a closer look at it. But skim through that real quick. Talk to people.
And Samantha, I'm going to try to shoot pictures of yours and send it to you so you can have that to study with.
That's why in Old Western movies they put their ear on the ground so they can hear the vibrations.
Did y'all remember when we got out the stick?
Yeah.
We're listening through the stick, right? Because sound travels faster when the particles are close together, not when they're far apart. Think about this. Have you ever gone outside on a really cold day? You know how sound sounds different? It's because the sound is actually traveling faster on a cool day than it is on a hot day. Because the air particles are closer together, because they're moving more slowly. Also, if there's snow, I think the snow kind of absorbs that radio really well. Y'all need something, please? Y'all need something? What's the question? Not since last night. We're going to go to the tomorrow class. Okay?
It's a shock to me.
All right, so I do want to remind everybody, like I said, I'm recycling questions, so you can be really sure you're going to see questions that people missed a lot. I might have made a few adjustments on some of them. So don't turn your brain off and just blindly answer exactly what you answered last time. I might change numbers that you have to calculate, or I might slightly rework the question or slightly change the picture, so you got to be on your toes. So we had 2 checkpoints this 6 weeks, checkpoint 6 and checkpoint 7, and I pulled 5 questions apiece from 6 and 5 questions from 7. Okay. As of right now, let me just pull up a thing here real quick. I was working on this today from when I stopped having sophomores to pretty much right now when you guys walk in. As of right now, I've got a semester test. Did I say semester? That's a mean thing. 6 weeks test for y'all. It has a total of 22 questions. Okay. Out of those 22 questions, 15 are multiple choice, 7 are short answer. And since there's 22 questions, the math doesn't work out just really well, so I thought I would set them at 5 points apiece. So there's a total possible score of 110 on this. Okay. So even if you totally fudge 2 questions, if you get 20 of them correct, you still make 100. Okay. Or if you get 21 correct, you make 110. And that's without proof. Out of that, the breakdown, I've got momentum and impulse. Eight questions. Work and power is 6 questions, and waves and harmonic motion are 8 questions. Okay, so it broke down pretty close. I did want to be sure that you had all the formulas you were going to need for this. Did y'all take some of these screen physics reference formula chart things at the start of the year? Okay. If you have those, you can get those out. Because I kind of think instead of me trying to refill a board, if all the formulas you might need, you might just look and see where they are on this chart. And if we're missing one, then we'll put that up on the list. So looking at this front page right here that says energy and momentum, the formulas on there that I want you to be sure you have right there. The first one right there is kinetic energy. Wait, were there any kinetic energy problems on this test? You might not even need that. That's it. No, I think I tried to shy away from the kinetic energy, so that's not going to be a thing. Alright, so we don't need to worry about that. Now the whole momentum equals mass times velocity. Okay, that's on there. So P equals mv. Right underneath that, we've got impulse is equal to force times change in time, and then there's the whole impulse momentum theorem right here that says like F times delta T, force times change in time, is equal to mass times change in velocity. Okay? See where that is right there? That's super useful. Law of conservation of momentum is right underneath that. That's super useful. You've got two objects that are going to either collide or come apart, like if somebody jumps off of a skateboard or something like that. Then the total momentum before the collision is going to be equal to the total momentum after the collision. Okay? So m1 times v1 final plus mass 2 times velocity 2 final. Don't forget, velocity is a vector quantity, so it can be either positive or negative depending on direction. Okay, that's going to be useful. Let's see, we didn't do anything with Q equals mc delta t, that's chemistry right now. Right underneath there for waves and light, you've got velocity equals frequency times wavelength. Okay, that's a thing. I'm not sure if it has a thing relating period to velocity. So that's one I'll be sure and leave, I'm sorry, or relating period frequency. I'll be sure and have that up on the board. Okay. Go ahead and look at your second page. Okay, so under force and motion, there's several things having to do with velocity, acceleration, displacement, net force. Now we get down to work, okay? Where work equals force times distance, or force times displacement. Power equals work over change in time. That's really all you're going to need, except if you look on the very last page, they give you some constants and conversions. And you know, at first glance, it doesn't look like there's really much there, but if you take a look under Hertz at the very bottom, Hertz equals cycles per second. Okay, that's another way to think about this right here. Okay, Hertz would be frequency. Okay, this would be cycles on top. This would be seconds on bottom. Watts, right above that, it tells you that a watt is equal to joules per second, or Newton meters per second. Okay? Watt equals joules per second, or Newton meters per second. newtons per unit of what? Total force. Okay? Meters is a unit of what? Distance. And seconds is time, right? Okay? Well, force times distance, this up here equals work, right? Work divided by time is power, which is watts. So that's formulas on the green chart. Does anybody not have a green chart?
I think I'd rather know that.
Okay. Well, I'm not going to let you use what you just wrote all down tomorrow, but I will let you use the green chart tomorrow. Okay. All right. And if for some reason y'all lose those between now and then, the version of the diagram or something, I can have that too. So, going back to just our big screen full of what's going to be on there, we've still got, let's see, it's 2:30. We get out of here at 2:54, so we've got 24 minutes. In those 24 minutes, we can either pick one or two of these topics and we can talk about it, or we can find some short cahoots that cover one or two of those and plan them. Okay? I don't want the cahoots to win just because they're loud. Okay? Who would like the cahoots? Okay. Who doesn't like the cahoots? No cahoots. Okay. I'm not going to force anybody to do cahoots, but if you want to play along on paper just to see how you do that, I think that would be a good idea. I'm going to go ahead and stop this review video, which I will try and post later along with links to some of these cahoots for those of you who aren't able to join us in person or somebody who wants to just look at them again between now and tomorrow. And we will take our tests tomorrow, which I'm kind of liking because if for some reason it takes y'all a really long time, then we have the freedom to kind of bleed it into Thursday if we have enough people that need to finish on Thursday. Okay? Okay, so let me see how I stop this thing. I think it's Control-Shift-K. Did that do it? Nope. Control